Hi everyone, I'm Julia Heider, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by SolidCAM. Machine shops can use 3D printing combined with CNC machining to produce more complex parts faster. Today's webinar will cover how metal 3D printing can enhance job shop manufacturing, how shops can future-proof their businesses through advanced technology and support, how to combine metal 3D printing and machining to achieve faster production, complex geometries, and tight tolerances, and how shops can use metal 3D printing for prototyping, fixturing, part consolidation, rapid tooling, and on-demand manufacturing. Our presenter is Emil Somekh, CEO of SolidCAM. Dr. Emil Somekh is a 38-year veteran of CAD/CAM development and applications following 10 years in the aerospace industry. He established SolidCAM in 1984 and as SolidCAM's CEO is deeply involved in product development, business development, marketing, and sales. SolidCAM's robust line of integrated CAM modules in SolidWorks and Inventor support the complete range of CNC machines, including 3 to 5 axis milling, multi-channel mill turn, and Swiss-type CNC machines. We're also joined by Anthony Calderone, who is the Chief Technical Officer. You can submit questions at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. And I also wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that, let's get started.
Hello, attendants of MMS Additive Webinar. I am Emil Somekh, CEO of SolidCAM. SolidCAM today is the leading CAM system worldwide, seamlessly integrated in SolidWorks, also in Autodesk Inventor, with amazing eye machining, the technology that saves 70% or more in machining time and increased tool life 5 times or more, and with its amazing technology wizard, and with the best support of multi-channel mill turn and Swiss CNCs. SolidCAM has been advancing in functionality for decades, and we have always found out that we listen to our customers to give them more of the functionality they need. So today, SolidCAM has reached the top functionality. So we're looking for additional services that our customers need from us. So we looked at additive manufacturing, or 3D printing it's called, and studied the subject. We found out for the last 20 years it was mainly used for prototyping and for a limited number of end-use parts. But lately, some companies have started making 3D systems for metal manufacturing. We checked them and we chose Desktop Metal, which has the most advanced binder jetting metal printing system. So we have looked at Desktop Metal. Here you see its main statement. Desktop Metal exists to deliver on the vision of 3D printing mass production. So you see here in this slide, Rick Fulop is the founder and CEO of Desktop Metal, which was founded in 2015. It had amazing growth since then, both organic and through acquisitions. They also launched Additive Manufacturing 2.0. They are world leader in fast metal 3D printing with their leading binder jetting technology. We have launched a partnership between SolidCAM and Desktop Metal on May 1, 2022. There was a press release about this launch, and as a part of this agreement, SolidCAM created CNC and additive manufacturing technology centers to provide close consultation and support to its worldwide SolidCAM customers on how to best leverage additive manufacturing to complement their CNC machining. Total look at the systems of Desktop Metal for metal printing. We have fiber, studio, shop, and production. We are going to concentrate now only on the middle two, on the studio system and the shop system. The Desktop Metal Studio 2 system has two parts, the 3D printer and the furnace. It's an office-friendly production of metal prototypes and one-off parts. You share examples of parts produced with Studio 2, a gear fixture, atomizer, and some gears. Okay, what's the qualities of the Studio 2 system? First of all, it's an office-friendly metal 3D printing in just two steps: print and sinter. What about the printer? Unlike laser-based systems that selectively melt metal powder, the Studio system extrudes bound metal rods, similar to how an FDM printer works. About the furnace, it is designed to be the easiest to use sintering furnace. So the Studio 2 system furnace first heats parts to remove all binders from parts, then ramps up the temperature to near melting to deliver industrial strength sintering to an office-friendly package. So we can use the Studio system to produce custom metal parts. Second system that we are interested in is the Desktop Metal Shop system. This is the world's first metal binder jetting system, designed to bring metal 3D printing to machine shops. It provides batch production of fully dense metal parts and produces parts with superior surface finish and resolution versus laser-based 3D printing systems. See here on the bottom right examples of parts printed with the shop system. The shop system printer features the most advanced printhead on the market with over 70,000 nozzles to achieve high-resolution 3D printed parts at a fraction of the cost of laser-based additive systems. Designed with the modern machine shop in mind, the shop system is built to fit seamlessly into the machine shop workflow. It produces parts with superior surface finish and resolution versus laser-based 3D printing. What are the uses of additive manufacturing? First, rapid prototyping. Quickly 3D print functional prototypes and thus reduce product development timelines. The Studio system is perfect for this task. Second, mass production. Produce hundreds of thousands of parts with no tooling required. The shop system is perfect for this purpose. And then the third use of additive manufacturing is manufacturing tooling to simplify the manufacturing process and reduce lead times for end-use parts. Desktop Metal have another line of equipment called E-Tech systems. They have the ability to mass produce polymer parts with the speed and quality needed for demanding end-use applications. They deliver parts with exceptional accuracy, superior part properties, fine feature detail, and smooth surface finish at a scale and cost that is competitive with traditional manufacturing techniques like injection molding. See here in the bottom right the different sizes of the E-Tech systems. So, to summarize, what are the uses for 3D printing? First, rapid prototyping. This has been the most common use for the last 20 years for 3D printing. Second is part consolidation. You see, sometimes to create an assembly, you have to CNC each part of the assembly and then combine together to make the assembly. In 3D printing, you could print the whole assembly as one piece. So it's a good example of part consolidation. With the 3D printing, you can do complex geometries that can never be done through CNC. Here you see an example of such a part that was produced with 3D printing. Next, design customization. You know, these days when somebody makes a design and then he does a prototype, he looks at it and then he wants a change and then he print it again and print it again. So using 3D printing can help you do design customization. And I mentioned before, with 3D printing you can produce rapid tooling. On-demand manufacturing. So today, if you have the 3D model of the part and you have a location where you can 3D print it, you can simply, whenever you need a number of these parts, you just 3D print them. That's what we call on-demand manufacturing. Supply chain re-engineering. Basically today, you don't have to produce parts, CNC parts in China and ship them to the United States. You just can simply print them where you need them, in the United States. So, to look at the complete picture, most companies today, whether they are SolidCAM customers or not, I'm talking about CNC machine shops, they really do not know how metal 3D printing can work for them. Also, as we've learned, there are many limitations to each of the different 3D printing technology. In addition, most 3D metal parts will require CNC post-processing, whether it's for drilling holes, locating surfaces finish, or ensuring critical tolerances. Basically, every machine shop or company that does manufacturing has some interest in metal 3D printing. It's a new manufacturing technology, and it complements CNC machining. So, SolidCAM task is to educate and guide its current CNC customers in 3D metal printing. We know the limitations and where this 3D printing technology excels. So, same as we provide practical technical support to SolidCAM customers for CNC machining, we offer the same for 3D metal printing. We can investigate a part and decide whether this can be done with 3D metal printing or not, and how much cost saving can be achieved with 3D metal printing, and what CNC post-processing is required. We can consult companies also regarding modifying the original SolidWorks design model, so we get a state of the model ready for 3D printing. Means holes are removed, additional material added to the machine faces, and other changes. So, how are we going to interact with our current customer? By taking real parts from you, we investigate how to integrate 3D printing in the process to manufacture your parts. So there are several different approaches. We just get parts from you for the purpose of studying them and understanding more where 3D printing can be useful. We can also 3D print parts for you as a service to you as our customers in our additive and CNC technology centers. Also, once you see the value of 3D printing, we can obviously also sell you the 3D printer system. Customer of SolidCAM in Germany called VMR. This customer gives services ranging from 3D printing with metal and additive manufacturing in plastic to design, mold making and plastic injection molding to CNC machining with milling and turning. VMR has 9 seats of SolidCAM and does metal 3D printing since 2014 with SLM and Renishaw laser metal printers. VMR plan to expand their metal AM services. They are now checking the desktop metal shop system, the binder jetting solution that delivers the high resolution 3D printed metal parts at a fraction of the time and cost of laser metal printers. Another area we are developing in SolidCAM is support for hybrid CNCs. Hybrid CNCs combine CNC technology and additive production processes. They have basically a regular milling head, and they have also a laser head to do 3D printing. We are going to support polymer printing, powder bed fusion, and also multi-axis additive manufacturing. You see here on the right the Okuma MU8000V Laser X is an example of a hybrid CNC machine. We have established now 5 SolidCAM additive and CNC technology centers worldwide. See here we have in the US 2 centers, one in Pennsylvania and one in California. We have a big center in Germany, one in the UK, in Israel, and in India. Here is an example of one of those centers, our SolidCAM CNC plus additive Schramberg Technology Center. It's in the city of Schramberg, 1 hour south of Stuttgart in Germany. Here we see on the left the shop system installed there. We see on the right the studio system, and we see on the bottom right other components of the shop system. You see here what we can do the whole process, which involves designing a custom tool. You see here the picture of the design. It was done in SolidWorks. Then we 3D printed with the shop system, and then we did CNC machining for creating holes and finishing surfaces. Let's see now a video of this whole process of custom cutting tool from design to finished part. Here we see the design of the custom tool in SolidWorks. Preparing it for the shop system. This is the shop system that has 70,000 nozzles that I explained. Here we're starting to print the parts. Now we transfer the printed part to the drying oven. Now we remove the unbound powder. Now the parts are ready for sintering in the furnace. Now we come to the last stage of doing CNC post-processing. We do the CAM part programming in SolidCAM, and now we take it to the CNC machine to do the actual post-processing. Here we are preparing the surface finish for the insert. Now we are drilling the hole for the insert. The end-use part ready for use. Enjoy the rest of the webinar.
Thank you, Emil, for your presentation. As employees and customers of SolidCAM, we are lucky to have a CEO who is so passionate and excited about manufacturing. I am not stretching the truth when I say Emil spends 95% of his awake time on SolidCAM. All of you should see a poll pop up on the webinar screen, and if you can, please answer that. Emil and Michael are currently at Formnext in Frankfurt, Germany. They both recorded their presentations last week for our webinar today because of that. If anyone watching happens to be visiting the show, please go to our booth and say hi to Emil or Michael. Tomorrow is the last day for Formnext, in case you're wondering. So I am here today to talk more towards our USA and North American participants. Emil's presentation was a great overview about SolidCAM and our journey into additive manufacturing. After my part, Michael Leditzky, our COO, will talk about their activities in Germany. So I am currently sitting in our technology center in Newtown, Pennsylvania. As you can see, sitting behind me is the Desktop Metal 3D printers. On this side here, we have the production-based shop system, and then we have the furnace almost directly behind me sitting next to it. And if I pan my webcam all the way to the left, you can see the studio printer over there. We are in the middle of expanding our technology center to be a one-stop shop and research facility for additive manufacturing and CNC applications. Once we've had it completed here, it will contain a Hermle C42 5-axis dynamic milling center, along with our Haas ST20 CNC lathe, the powder and filament-like based Desktop Metal 3D printers, and the furnace that also behind me. And then we are also adding the Desktop Metal Envision 1 XL resin-based printer that Emil talked about in his presentation. And we will also have different support equipment, including laser scanning and sandblasting and things like that to aid in the complete CNC and additive manufacturing process. Now, what I would like to say to everyone, especially the engineers and manufacturing staff here, is that we at SolidCAM are here to be partners with you to learn and apply metal 3D printing and CNC post-processing. I think it's clear to everyone who has knowledge in 3D printing that it's not a magic button to making parts. When we design a part and then CNC machine it, this process requires knowledge in the application ahead of time, and then the knowledge to design and machine this part. Additive manufacturing in CNC is quite similar in that regards. We simply cannot design and print with no concern for limitations or constraints. As CNC machinists, we've all learned, either from others or through trial and error, how to CNC machine parts. We know based on the equipment we have, milling machines, turning machines, sheet metal, bending presses, etc., what we can machine and how tough it will be to machine this part, and along with the costs associated with that. Since additive manufacturing is such a new technology, none of us existing CNC experts have knowledge or experience on AM or additive manufacturing. Now, some of us, like myself, have owned hobby grade plastic printers. Unfortunately, hobby grade $200 metal printers are not available for us to use at home. Well, at least not yet. Let's hope in the future. This is why I'm saying we're looking to be partners with you on metal 3D printing and CNC post-processing. We're going to work with you and our customers to find the correct applications and to build this knowledge so all of us can benefit from this technology on real production parts. 3D printing is not a fad or something that is going to go away. It's not going to replace CNC machines, but it will complement them. At some point in the future, we will all see 3D metal printers as another tool sitting in our machine shop alongside our CNC mills, turning centers, mill turn machines, grinders, and more. The reality is that the technology with Desktop Metal exists today to print fully dense metal parts for production and use. The main component missing here is the knowledge and application to implement it for the correct processes. Now, this includes understanding how to make design changes for AM, additive manufacturing, understanding how to integrate fixturing into the 3D part, And then maybe even using probing on a CNC to align our complex near net part geometry so we can easily CNC machine our critical features. Now, I'm not saying that every part would require this, but we are talking about trying to solve different challenges than machining a part from a solid block of metal. We will learn together with you how to solve these challenges. Now, with regards to the 3D printing envelope of metal parts, I'm not sure if that's the right phrase, but hopefully people understand what I mean by envelope. We're speaking about parts that are in the grapefruit or softball size and below. And we're along with wall thicknesses that are less than 1 inch for our powder-based shop system. With the Studio 2, with that being similar to like a filament system, it can print thick wall, but the wall will end up being semi-hollow inside. So in other words, we could print like a 3-inch cube, but the actual wall thickness will be about 3/16 of an inch, and then the inside of the cube will be a semi-hollow infill structure for strength. I think anybody who does 3D printing in plastic knows what I mean by that. So I do have some parts here to kind of go over and kind of talk about the envelope. So here's a here's a thicker part, and this is meant to show that like 1 inch wall thickness that you can do on the shop system. So this is a stainless part, it's very heavy, so this shows you how thick of a wall you can make. Let's grab another part here. We can also do very, very small, thin little brackets. So this is, here's a pretty thin wall thickness. You can see the holes are in there. We talk about CNC post-processing, but sometimes you're going to have parts that probably meet the tolerance that you don't even need to do any CNC post-processing. So, if it's a simple latch, you might not even need to drill the holes. It might just be perfectly acceptable coming off of the 3D printer, which is pretty cool. Here's a clipper head. So this is pretty neat. I actually like this part a lot because this is pretty cool because it really shows a nice little example of you really would print this complete and then really just machine off the back and polish the back if you want to get the cutting edge, and you get that complete. Here's a part I got here, which is like a drive coupling, which is, I don't think you'll see it so well through the webcam, maybe if I rotate, but there's actually like geared mesh on the inside, and then you can see the drive unit on the back. So really a part like this is you wouldn't need any CNC post-processing on something like this. So this definitely, this is meant to be a drive coupling with some, give and some inaccuracies in it, except for the spline on the inside. So, there's definitely neat parts that you could print fully without any CNC machining. Let's see. Of course, the other side of 3D printing that's really cool is you can print parts that have complex geometry that we really couldn't machine. So we can do things like grooves and tubes and things, structure inside that we couldn't CNC machine, at least in an easy way. And yeah, I think that's pretty good for the parts. And we made a little eye machining for NX side. So yeah, lots of different parts. So I hope that all of you can visualize parts that you manufacture and have a general idea of what class of your parts fit into that description. Because obviously we're not talking about giant parts the size of your table or something. So the materials included, but are not limited to, are stainlesses, titanium, copper, and others. Based on what printer we're talking about, they can have slightly different materials that they can do. Desktop Metal is qualifying new materials all the time. Stainless is really the bread and butter, I would say, because stainless really is the one that makes a big difference too, and I think I'll talk about that next, why I say that. So I would like to end with that I and we are asking that anyone who believes that they have parts which fit the description and are interested in 3D metal printers to reach out and contact us. We would love to work with you. You probably have parts that are designed based on CNC machining, but could benefit from simple design optimizations, or maybe even a completely new design in another material. We all know that aluminum is chosen for many of our machining applications due to its weight and the cost of machining compared to something like a stainless steel. But since 3D printing spits out a near net geometry, it might be beneficial to switch an aluminum component to a stainless and update the design, knowing that we can make modifications since it's stainless, like we can decrease wall thicknesses to try and meet, a weight specification if we need it. You can reach out to us by going to www.solidcam.com and clicking on additive in the top bar. Our direct AM team's contact email and phone number are at the bottom. You can also call our main USA line at 866-975-1115 at extension 35. And if you are currently a SolidCAM customer, just call your account manager. They will get you in contact with the right people here. Now I will let Michael talk and give us the overview of their activities in Germany. And then after that, we'll do the Q&A session. So if anybody has any questions, please put that in the Q&A panel in your webinar screen. Thanks, talk to you in a couple minutes.
Hi everybody, also from my side. Let me introduce myself briefly. My name is Leditzky. I'm the CEO Global of SolidCAM. Recently, we started to educate ourselves in the additive manufacturing process. And in this presentation, believe me, it's a short one, I would like to talk about what we have done as SolidCAM Additive Germany and what we are going to do in the future. So I think we should start, shall we? So the future now is very easy to say, but what does that mean? We have a little bit of a head start compared to our colleagues in the US and also everywhere else in the world, because we started additive manufacturing relatively early here in Germany. Today, as I mentioned earlier, I would like to present how far we have come, what experience we have gained, and what we will do in the future in this additive field. As we heard from our CEO, Dr. Emil Somekh, we have placed SolidCAM additive and CNC technology centers all around the globe. And there is, in the middle of this map, there is a small country which hopefully everybody knows about, and this country obviously is Germany. So let me zoom in here a little bit more. Good. Our headquarters is based in Somekh, which is the beautiful black forest in this area. This is also the center of the medical industry in Germany. We also have branches in Sinsheim, Siegen, Hörstel, Suhl, Neumarkt, and Rosenheim. I'm from Rosenheim, just if somebody's interested in hearing it. Having branches in all those regions is very important to be close to our customer base. But another really interesting aspect is that we had our own CNC machines for over 10 years. We test our software. We want to show our customers the whole process from the beginning to the final or the finished part. So the completely manufacturing process. And recently, we have also introduced in this technology centers additive manufacturing. So what we have added in combination to our Hamlet C30U, our DMG NTX 1000, and our Citizen L20 ATC is a desktop metal Studio 2 system, a desktop metal shop system, and I think in 2 or 3 weeks we are getting an eTech Envision 1XL and an eTech D4K. That means we can show now the full process from designing a part, printing it, putting it in the furnace, and then we do the CNC post-processing. And this is something we are really proud of because we can show this in one environment. So we can grab our customers by its hand, just tell them, okay, with us, we will show you exactly what you need to know. A little bit more facts about SolidCAM Germany. We are 74 staff. And what is really interesting about it, that 28 of those 74 staff are application engineers in CAM and additive manufacturing. We have more than 4,000 customers in Germany, Austria, and Switzerland, and we are really proud to have almost 13,000 educational seats as well. And especially in the educational area, additive manufacturing is something that is going to be really important in the future. Let me give you a small virtual tour of our technology center in Germany. So let's zoom in a little bit more here. When we enter our building, we are staying directly in front of our Hamle C30U 5-axis machine. So as you know, AC axis, spindle, pretty straightforward. It's a high-down controller on it, which is pretty well. Then let's zoom a little bit out. Let's try to go to our NTX here, which is based here. It is a 2-channel machine with a Siemens controller. We have a B-axis, a rotary turret, a lower rotary turret, main spindle, and back spindle. At the corner here, we see a Citizen D25. Meanwhile, this machine is going to be replaced by a Citizen L20 ATC. And at the back side here, where this wall is here in the 3D scan, there is the breakthrough to our additive technology center. So let me show you how this looks like, because we haven't scanned it yet. When you enter the room, you see the Desktop Metal shop system here on the right side. And we also placed, as I mentioned earlier, the Desktop Metal Studio 2 system in it. You know, those printers, they run almost every day. We print prototypes, functional parts like we have seen earlier, the cutting tool. There are actually no limits. We are exploring daily, and our customers approach us. They give us parts, we print them, we try to, you know, redesign the parts with our customers. So actually there are no limits, and we can now produce parts that we would never have dreamed of before. It's absolutely worth seeing and a great added value for our customers. So if there is any chance for you to visit one of our technology centers in the future, visit us. It's worth it, believe me. There are also some peripherals that we need. There is on the left side, you can see the depowder stations, and on the right side, you can see the drying oven, which is used to activate the binder after the binding jetting process. And then, of course, we need to remove the excess powder, and it can be also completely recycled. That means there is no unnecessary waste of powder, as it is the case, for example, with laser sintering. So one more time, I want to mention it. What we are going to do right in a moment, or what we are doing now in Germany, is to educate ourselves and to educate our customers. So this plan is very clear. So what does a CNC production or a CNC machine shop look like today? Well, it's quite simple. We all know it. We have different machines, milling, turning, Swiss type, but you know, there's a new player in this game, namely additive manufacturing. So let's put that right next to the CNC machines just for this illustration. So we have those two technologies here, and we have to combine them. And in the intersection in the middle, that's exactly where SolidCAM Additive is. We are the link between additive manufacturing and the CNC manufacturing companies out there. Last but not least, I would like to show a picture of the additive team that was, you know, the team for trade show here, which was called the METAF. And we were also supported by really nice people from Desktop Metal. Beautiful exhibition. We saw so many people approaching us and ask about 3D printing. It was quite awesome. So, and what should not be missing in a good webinar from Germany? Of course, a short report of the most important trade show we have, which is the AMB, where we showcased our whole process, including additive manufacturing, for the first time. Enjoy.
Hi and welcome to the AMB 2022 here in beautiful Stuttgart. The AMB in Stuttgart is for us one of the most important exhibitions that we have. On the AMB 2022, we utilize two machines. The first of it is a DMU 60 Evo Linear. On this machine, we are manufacturing, for us, a really important part. It is our technology center in Schramberg, which is also the headquarters of SolidCAM Germany. You can see clearly on this part that it's really hard to machine. You have deep undercuts, you need long tools, you need also barrel cutters to finish this part. Next on our booth, we have another technology, which is Swiss type. On Swiss type machines, it is always really hard to make sure that you're not having collisions. So we built a system in the last couple of years to program these machines in the best and easiest possible way. In this case, we have a Citizen L20 ATC. The Citizen L20 ATC is one of the first machines that has a tool changing mechanism for the B-axis. The part we are doing on this machine is a dart. This dart is a part that is really meant to be machined on a Swiss type machine. Of course, it's a show part, but it is long, it is thin, and you need Swiss type machines to program parts like this. Next, it is a world premiere what we are doing here. We are showcasing our approach of additive manufacturing. Additive manufacturing is one of the most important technologies in the future, and I believe that this technology will be placed in a lot of machine shops or almost any machine shops in the future, because the printers, they get more cheap, they are faster, the parts that they machine are really accurate. And for example, what we see here is the Desktop Metal Studio System. The Desktop Metal Studio System is meant to produce prototypes. It's meant for small batches. Also some repair shops that are doing some spare parts is this product perfect for. On the other side, back there, we see the Desktop Metal Shop System. The Desktop Metal Shop System is the first binder jetting system that is commercially available on the market. In binder jetting, in comparison to the Studio System, it is not about single parts, not about spare part. It is about mass production of metal parts. And when we talk about mass production, of course, we target the CNC sector. And the CNC sector is always needed to post-process parts like this, because we have tight tolerances. We also have surfaces that needs to be machined. So it's the perfect art for CNC manufacturing is Desktop Metal Shop System.
All right, what a nice video. So let's design the future together and make it real. Thank you for your attention.
I hope everybody enjoyed listening to Michael's overview of Germany. Obviously, they have a very impressive and technologically advanced group of people over there and facilities. So it's always awesome to see what they do there. I think now we're going to move on to the Q&A section.
All right. Thank you, Emil, Anthony, and Michael. It looks like we're starting to get some questions already, but there's still time to submit one. You can do that using the Q&A tab at the right of your screen, and we'll do our best to get to it today. If we don't, someone can follow up with you via email. So our first question, what tolerances can you achieve with 3D printed metal?
Okay, so in general, we could say 11 thousandths.
Is that regardless of the printing process?
Yeah, that's pretty much regardless of the printing process. I mean, the sintering process is obviously, you know, the parts are deforming a bit in the sintering process, but one of the amazing technologies of Desktop Metal is their software technology, such as Live Sinter, which is actually predicting how the parts shrink and grow in the sintering process. So 11 thousandths is a number that we can actually hit for real.
Okay, what finishing options are available?
Yeah, it's a good question. So, I mean, since it's a metal part, it's pretty much the same finishing processes all of us are used to in machining or any metal parts. I mean, we could, you know, the parts kind of have like a slight grit to them. It's I don't know what we would call the surface finish, maybe like a 125, maybe less. But you can, I mean, they can be polished, they can be buffed, they can go a tumbler, they can be sandblasted, glass beaded. I mean, really, it's the same things we do in CNC machining is really the same. You know, I do actually have. Wait, is this watch face? Yeah. So I mean, here's like this is like a watch face, and you can see a little shine to it. So this was just like tumbled. So as opposed to maybe if I hold up both at the same time, the webcam probably doesn't do that awesome of a job with this, but you can see the watch face has a little bit more of a shine to it, where like the part that just comes out is just a little bit duller. But your options pretty much are the same.
All right. Why is 1 inch thickness the upper limit?
That is an awesome question, and it was one I had to have our AM experts explain to me, because just like everybody here, I'm kind of new into 3D printing, so I am by far not an expert in it. So it kind of goes it goes like this, and probably a material scientist at DM would probably roll over in his grave if he heard me say what my explanation. But basically, what we have is there's a binder in the material. So whether it's in the rod-based filament system for studio, or whether it's a powder, there is a binder, and that binder it's not metal, right? So it's not our stainless, it's not our titanium, it's not our copper. That exists only to 3D print the part. We have to remove all of that binder. It needs to be removed, or else it wouldn't be stainless if there was other material in it, such as the binder. So what happens is 1 inch wall thickness is about the limit that in the sintering process that the binder can actually evaporate and I don't know if the word is permeate or escape the actual metal part. So if we think about this, when we have this 1 inch wall thickness, if you think all the way in the middle, there's a glue. That's basically what the binder is a glue. So in the furnace, it needs to heat the metal up to such a point that the binder is actually fully escaping, so there is no binder left in the part. That is definitely the bread and butter of what makes DM so awesome and their parts so amazing. Like when you saw the tool holder in Emil's video, you could see that like when you take a cross section of these parts, it's normal metal. You don't see any waves. You don't see any grain structure. Like I think isotropic is the right word. So yeah. So this 1 inch wall thickness is due to that. And like I said, in the studio system, because it's a little bit different, it's a little bit less than that. But we can do like big cubes because we're doing infill. So you can do semi-thicker wall thicknesses if you want to consider it a wall thickness. If if it has infill.
Thanks for that explanation. Our next question. In Emil's video, the area of the sintered part held during machining was as sintered. Would it be common to inverse it into a corresponding holder and then machine those as sintered surfaces?
It's so cool. I definitely tell it. I think this is from Clement. Definitely total machinist question. Yeah, absolutely. When we, I mean, it was kind of like a show. It was a showpiece for us, and yes, definitely, it would be pretty cool to put that into a holder and actually machine it from a holder. In the time constraints of us, we were, I can tell you, we did that in just a few short weeks before IMTS to get it to IMTS. So, the simplest thing was just, take an aluminum block and, bore, circle mill the hole and be able to bolt it from the top. But yeah, definitely. I mean, that was also my first thought when, when we designed the piece was that, we just stick it in a holder and then you could just machine it while in the holder. But well, you got to hold the holder somehow. And I think as machinists, we know there are different clamping devices that literally hold Cat 40s or HSK holders and things like that. So yeah, that was an awesome little understanding of seeing that. And yes, I would agree. Yeah, that would probably be a better way to do it.
All right, we have a couple of questions about materials here that I'm just going to roll into one. They're asking about 4041 heat treatable and titanium.
Yeah, so both of those materials are available. I am pretty certain that both of those materials are done on studio and the production-based systems because of atmospheric reasons. So I don't think the shop system does those, but the filament-based one and the bigger production, which is still a powder. The production system is still a powder-based, but the it's able to control the atmosphere in the build, in the printing chamber.
Is post-process heat treating needed for these metal printed parts?
No, they are not. But obviously, if you're talking about wanting to do some additional above and beyond heat treating, then you could. If you go on, the cool thing is if you go on Desktop Metal's website, you can get the material specs for the different materials that they have. So when you're going to see their Desktop Metal 3D printed parts are so close to our our normal stainlesses and stuff that we would buy for machining. So if you want to do some heat treating or something afterwards, it would be kind of the same, it would be your request to do that. Not something you have to do, but you can do.
All right. Do we expect the tolerancing will get better over time?
Cool. I think it would have to. These are kind of the topics we've had internally with our teams. Is does the tolerancing get better? The other, I would say with machining, it's kind of the same thing, right? Like when we machine a really tight tolerance, something to like tenths, if we're in the inch world, the first time we go and machine it, we expect the CNC and the end mill to like make it perfect, right? Because why shouldn't it? The CNC servo system can move to, it can move tenths, and the tool, we can mic the tool and it's exactly a 1/2 inch diameter. And so it should absolutely meet our tolerance, but we have to do like compensation out at the controller. So we have to adjust for flex and things like that. 3D printing it's not exactly the same, but you can, like when you first print your part, you're obviously not going to hold. I mean, I would never say we're going to hold like 2 or 3 thou. I don't know. Maybe we can. We are definitely going to push it to the max because we want to know what type of tolerances we can hold. I think the reality is going to be the type of part that you print will control how well we can continue to modify the model, same way that we compensate G-code programs, and to get it to repeat. I mean, the beautiful thing about the 3D printing system is that the way it repeats should be very good. So I think this comes more into about repeating the same process and hitting the same tolerances. So yeah, I don't know. I mean, if you ask me probably in 6 months, I'll probably be like, yeah, we found out how to make a 1-inch cube that's like perfect. Maybe not perfect. Maybe it's with, we can print batches of 1-inch cubes that are within 1 thou. But obviously that means just because you stick a 1-inch cube on some bigger part that's sitting over in, another area, it doesn't mean it'll be 1 inch in that, because the biggest thing here is the sintering process is changing. You have gravity, and it's changing it a little bit. And, the material, while it's held constant, it's not pure 100% that you'll get the same thing every time. So I don't know. It's a cool question. It's one we're asking ourselves here, and that's what we will. That's what we'll aim to find out with our customers. So I would say if somebody has like a specific example where they need to hold some tolerance, we will see if we can hold it. And when the 3D printing can't, that's why we have our CNC machines.
Since there is no grain structure in AM, how strong is it compared to products with grain?
Cool. So I don't know that I definitely wouldn't be qualified to answer that question, because I am not that type of material specialist to answer that question. So yeah, I mean, obviously, as we know, in the direction of the grain, we know that we make parts that way, and they have their strengths that way. So I don't have a good answer for that one. If you want to contact us, then I'm sure we can get that answered, and also talk with DM to maybe quantify that. I wouldn't even know how to quantify how it compares or what would be the difference. But obviously, like you said, it doesn't have grain, so there's going to be a difference. But in some applications, it might be considered better because there is no grain. It's isotropic. So I wish I could answer it better.
All right, I have one more question here. So if anybody else has something they want to ask, make sure to get that in as soon as possible. The question is there any opportunity for existing product development shops to collaborate or participate as resellers showcasing this technology?
Repeat that one more time
Yeah.
for me. That way I
Okay.
can.
Is there any opportunity for existing product development shops to collaborate or participate as resellers showcasing this technology?
I would think that answer is yes. I mean, we already, I know Emil mentioned in his presentation a little bit about, SolidCAM being able to be like service centers. We are not in the business here at SolidCAM to batch print parts for customers for that. That's not our idea. Our idea here is to help customers print parts, understand that they meet their specifications before, let's say, a customer would invest in their own to buy a printer. When we have customers that, let's say, are not there yet to do that capital investment, but they want to be able to go down that path, we're going to look from our side to partner with different companies that actually have the 3D printers equipment and are willing to be bigger service centers and do batch production and work with our customers. So I think the answer to that question is yes, and I would say reach out to us and we could better understand what you're looking to do. But yes, we're definitely about partnerships here. This is and we don't want to we're not trying to do everything ourselves. We really want to be the R&D and fit all this stuff together and get the have the printers run in production at either customer sites or other service centers.
All right, that's all we have for today. I want to thank Emil, Anthony, Michael, and SolidCAM for making this webinar possible. And thank you to everyone for listening in. You should receive a link via email to the recording soon. Thank you for your time and enjoy the rest of your day.
Thanks, everybody. Have a good one.